It's always good to talk about the assumptions of any of the statistical methods that we're using. Some of the main assumptions of this ANOVA technique, analysis of variance. If I told you that ANOVA stands for analysis of variance, maybe I'll write that in here before I forget. Analysis of variance. That's equal to your ANOVA, and that comes from the fact that, if I get my highlighter here, right, we've got AN for ANOVA. Perfect. Okay, so the assumptions of this thing here are that all the populations are independent within and between groups. Usually if you want to analyze that for a particular data set, you really have to think about how the data was collected. So you're going to want to make sure that, you know, the different observations were chosen independently, that there was some kind of randomization that was done of our sample. Okay. The observations within each group should be normally distributed. So there's a couple different ways that we talk about assessing normality. Quite often in this class, I tell students just to look at sort of histograms. Okay. And while all those histograms do not look perfectly normal, keep in mind here that we only had 10 samples in each group, right? So it'd be really difficult to really show it, but all of them look like they have one mode and they seem to sort of go downwards on both sides. I'm feeling okay with that. So again, sometimes this gets trickier to assess when there's small sample sizes. A lot of people, especially if you're inexperienced, wouldn't be really sure whether this is normal enough or not. Another technique that sometimes people like to use is something called a QQ plot. And that's what these are here. Okay. I'm not going to talk too much about how the math behind how these are constructed, but I will talk a little bit about how we analyze them. So what I'm hoping for, if the data is perfectly normally distributed, that means that all of the points will fall exactly on a line. Okay. If the data points don't fall on that line, that means that they're not perfectly normally distributed. So while these don't fall perfectly on the line, they do sort of seem pretty close to falling on this line. Maybe this one's a little less perfect than some of the others, but if you construct these QQ plots, as long as they fall sort of reasonably around the line, that might be okay for you to assume that they're normally distributed. So maybe I'll just write that here. If data is normally distributed, points will fall exactly on the line. Okay, so we're hoping for the points to fall somewhat close. And again, that's a judgment call. That would be something to sort of check. The other last assumption that we haven't talked about ANOVA is that all the populations have a similar variance. So maybe I'll even just go back to our side-by-side box plots here. This one definitely has a bigger variance than this one and this one. Like, look at these standard deviations. Those numbers aren't exactly the same, the sample standard deviations, but they're not dramatically different. So in this case, I'm thinking it's okay for us to assume that the variation in these is about the same. There are some statistical tests that we can talk about for how to test that, but in this class, we're going to be a little bit more hand wavy, where we just say, yeah, that's pretty good, that's pretty close. Okay, they're not super different. Okay, so once we've kind of verified that those three assumptions are met, or at least are close, then we can proceed with the rest of our analysis.